Today, we're going to run a Monte Carlo simulation that uses probability and randomness to simulate a basketball tournament where we compare 7 legendary basketball teams from 1995 to 2023 to predict which legendary team has the highest probability of winning. When these legendary teams collide, the battlefield won't be on the basketball court. It will be built into a data-driven model to simulate a team's true probability of winning. That is, every single rebound, every point, every assist, the speed of the game, defensive matchups and offensive schemes. Every single data point that defines greatness on a basketball court will be built into a Monte Carlo simulation, where we will generate thousands of matchups between these 7 legendary basketball teams to predict a team's true probability of winning. To generate a basketball tournament built upon a Monte Carlo simulation, we first need to select 7 legendary basketball teams from 1995 to 2023. Each team will be selected based on their historical impact on basketball. The first team that will be selected will be the Chicago Bulls from 1995. The Chicago Bulls destroyed every team during the 90s and won 6 basketball championships, with the greatest player to ever play the game being Michael Jordan. The second team that will be selected for our tournament will be the LA Lakers from 2001, who won 3 consecutive championships between 2001 and 2005, with their leader being Kobe Bryant. The third team that we have selected is the Golden State Warriors from 2015. Many experts consider this team to be the most dominant and offensive force the game has ever seen, with the greatest attacking player to ever play the game being Steph Curry. Miami Heat from 2010 is also included into our basketball tournament. Miami Heat won 2 basketball tournaments and made it to the basketball finals 4 consecutive times in a row, with their leader being LeBron James. Detroit Pistons from 2007 is also included into our tournament. During 2007, they were known for their toughness and defensive ability to shut down any attacking team in the competition. The other teams included into our tournament will be the Phoenix Suns from 2020, who are known for their attacking capabilities, which is being led by Devin Booker, who represents the new generation of basketball players coming through. And finally, the Boston Celtics from 2023, who won the basketball competition last season and are therefore considered the benchmark for the best team in basketball. Now that we have selected our 7 legendary basketball teams, it's time to collect and process key data analytics for each team. These data points will form the foundation of a data-driven model. That model is known as a Monte Carlo simulation, which uses randomness and probability to simulate thousands of matchups between these legendary basketball teams to predict each team's true probability of winning. The key data points that we need for the Monte Carlo simulation is the average points scored per team and the standard deviation in points scored per team. These data points reflects a team's attacking capabilities. To collect these 2 key data points, we will use Basketball Reference, which is a reliable website for basketball analytics. With that being said, for the data collection processing, we will use Basketball Reference to find the average points scored and the standard deviation in points scored for each of the legendary basketball teams. Now that we have the 2 key data points for our 7 legendary teams, we can now start building our Monte Carlo simulation to predict which legendary basketball team has the highest probability of winning. We will select the Chicago Bulls from 1995, with the average points scored being 105 and the standard deviation in points scored being 10. The other team will be the Phoenix Suns from 2020 with an average points scored being 115 and a standard deviation in points scored being 11. With that being said, we will use the following Excel functions to run a Monte Carlo simulation to simulate a basketball score between these legendary teams. But first, let's explain what this Excel function means. We will start off with the easy part, the mean and the standard deviation. This just reflects the average points scored and the standard deviation in points scored. Now in basketball, is Chicago Bulls always going to score 105 points with a standard deviation of 10 points? The answer is no. But why is the answer no? Because there's always going to be random fluctuations in a team's performance, whether it is in basketball, football, netball, or the share market. There's always going to be random fluctuations in a team's performance. So when simulating a team's performance, we simply add that randomness into our model using the rand function. This function will generate a random number between 0 and 1 after every simulation. It simply represents the random fluctuations in a team's performance. The norm inverse part is simply just a fancy way of saying that the data, such as the average points scored of 105 and the standard deviation of 10 points, come from a normal distribution. If we expect the data does not come from a normal distribution, we simply use a different Excel function. Now that we have explained the formula, let's use it to simulate the points scored per game for the Chicago Bulls. Since we are assuming the data for Chicago Bulls comes from a normal distribution, we will use the norm inverse function. And since we want to add the random fluctuations that naturally occur in a basketball team's performance, we will use the rand function. Now we will select the average points scored per game by the Chicago Bulls and the standard deviation in points scored per game for the Chicago Bulls. After running the Monte Carlo simulation for the Chicago Bulls, we can see that the model generated a score of 116 points. This closely mirrors the team's average points scored when considering the standard deviation in points scored, plus the added element of randomness that was built into the model using the rand function. Each time we press enter, the Monte Carlo simulation generates a new score for the Chicago Bulls. If we simulate 5 different games, we will get 5 different scores, reflecting the natural variability and randomness in Chicago Bulls team performance. We will now repeat the same process by using a Monte Carlo simulation to generate a simulated score for the Phoenix Suns. Since we are assuming the data for the Phoenix Suns comes from a normal distribution, we will use the norm inverse function, and since we want to add the random fluctuations that naturally occur in a basketball team's performance, we will use the rand function. Now we will select the average points scored per game by the Phoenix Suns and the standard deviation in points scored per game for the Phoenix Suns. We can see that the model generated a score of 95 points. This closely mirrors the team's average points scored when considering the standard deviation in points scored, plus the added element of randomness that was built into the model using the rand function. Each time we press enter, the Monte Carlo simulation generates a new score for the Phoenix Suns. If we simulate 5 different games, we will give 5 different scores, reflecting the natural variability and randomness in the Phoenix Suns team's performance. Now, after running a Monte Carlo simulation to simulate a score for the Chicago Bulls and for the Phoenix Suns, we can see that in match 1, the Monte Carlo simulation simulated a score for the Phoenix Suns of 122 points and 117 points for the Chicago Bulls. This means the Phoenix Suns was the winner for that simulated match. Likewise, for match 2, the Phoenix Suns also won. This means across 2 simulated matches, the Phoenix Suns from 2020 has a 100% probability of winning against the Chicago Bulls from 1995. However, what if the Phoenix Suns just got lucky across those 2 simulated matches? What if they play each other 10 times? Would the probability change? And would we still say they just got lucky? What if we simulate 100 matchups, 500 matches, 1,000 matches, and even 10,000 simulated matches? Would the probability change? And would we still say they just got lucky? Or maybe after 10,000 simulations, the outcomes start to reflect a team's true probability of winning. With that being said, we can now compare the 7 legendary basketball teams against each other to find out which legendary team has the highest probability of winning the basketball tournament. For example, based on 10,000 simulated matches using a Monte Carlo simulation, and the LA Lakers from 2001 versus the Miami Heat from 2010, there's a 50% probability of both teams winning, suggesting a highly competitive matchup against these legendary teams. We simply repeat this process for all 7 legendary teams and record the results to find the winner. In the end, the Boston Celtics from 2023 win the tournament. We can assume our model is not perfect and has many mistakes. However, from a learning perspective, we have just used data analytics to build our very first basic model. So by the time we finish university, we should be able to build upon a basic model into a much more complex model to not only predict the probability of a basketball team winning, but also predicting the probability of a business proposal increasing profits or productivity in a corporate environment. We can do all of that and more with a Monte Carlo simulation.